optical fiber going to Antarctica yet, so then you have to use satellite. So if you do go to Antarctica, you're not going to get an optical fiber even in Svalbard. Okay, I've been to Svalbard. I've been to this island actually. I've been to this island, and then you get a perfect optical fiber network. Okay, even up there. All right, so this is how the whole world is linked with optical fiber. Okay, so now let's get back to our microscope. Okay, which is now we'll discuss electron microscope. Light microscope, as I said, you cannot see anything less than 200 nanometer. And then now with electrons, because they're shorter wavelength, you can actually see things in greater details. And then we will take a look at two different common ways of getting electron microscopy. So in the transmission electron microscopy techniques, you have a scope that shoots out electrons going through the sample, and then you focus it with magnets, and then you generate an image on the screen. Okay, so this is called transmission electron microscopy because the electrons are actually going through the specimen, kind of like light microscopy, right? So you do that. But this is a much more difficult technique to use. This is quite difficult. You have to actually make a very, very thin section. So most universities don't have that. You need a special unit to actually process TEM samples. You have to make very, very thin sections. But the goal is to look actually inside the cell. Okay, if you want to look something inside of the cell, you need to do transmission electron microscopy. Now, more common electron microscopy technique is actually called scanning electron microscopy, which we actually do have one. All right, so the university suddenly gave us $70,000, and then we actually purchased a scanning electron microscopy. So we will actually give you a demonstration, in a couple of weeks. And in the scanning electron microscopy, what you do is the electrons, you put the sample here, and then instead of the electron going through the specimen, the electron actually bounces off on the surface of the specimen. And then you measure then you pick up the electrons that is bouncing off the surface of the specimen. Okay, so this technique is called scanning electron microscopy. You're only looking at the surface of the organisms you put in. You're not looking at the details. You're not looking at the inside. You're only looking at what is bouncing off on the surface of the specimen. And it still gives you, a three-dimensional image like that. It gives you quite high resolution, okay, down to 20 nanometer, quite a bit better than the light microscope, okay. So we actually do have an SEM. It's a $75,000 machine that the state gave us money for. So we have money to buy an SEM, but we don't have money to give you lab coats, okay, to give you gloves and things. All right, so we'll give you, so you have to buy your own gloves, but we'll show you how a scanning electron microscopy works. That's how it works. Because the state actually specified these money for buying equipment only. They say you cannot spend this money on reagents and consumables. We have to spend it on fancy equipment. The state suddenly dumped us, they dumped us $120,000. I bought a full photometry machine just sitting over there. And then we bought a scanning electron microscopy, which is in the chemistry lab. So we have fun machines to play with, but you still have to buy your own gloves. Okay, so that's the bottom line. All right, let's actually take a short break here. Okay, so let's take it's almost 10. Let's take a short break here. Let's do like a little 5-minute break here, and then we will finish this chapter, and then we can talk about some structure.
Professor?
Yeah.
This chapter is not on the lecture test.
Just